Let's talk about SQL a little bit. Um, SQL, great. We are, well, where do I want to start here? Um, yeah, cool. Um, so here's the deal with SQL. It's super useful. It's really good to know. It is asked about in interviews an awful lot. Um, and depending on what you're doing, you will probably not actually be touching it very much. Um, most modern, a lot of modern things that you should be using, including SQL Alchemy, or if you use Rails or any of the 1 billion ORM libraries, um, or even a query builder like Connects or something, which is my favorite. Um, you're not going to be touching SQL an awful lot. You'll occasionally have to tweak things or make custom queries, but unless like that's the job, um, you can get away with not knowing SQL for a really long time, I think. That said, it is really useful to know, because when your ORM or query builder or whatever you have breaks, or it doesn't break, it doesn't do what you expect it to do. It's knowing SQL is even just a little bit is going to make it a lot easier to be able to debug that and understand what's going on. So here uh, we have actually expanded the SQL stuff a little bit since even since last time, but I think the what we need to know is the basics, because we are going to be um, before too long hooking up our Python object models to an automatic database hooker upper thing, ORM, SQL Alchemy. And so our need to understand the SQL is going to diminish rapidly, and then increase rapidly again when there's bugs. So I'm going to go over the basics here and play around with some stuff in a little database I have here. And yeah, it's going to be kind of a whirlwind tour, I think. We're not going to go super, super deep into any of the parts, but if there are any parts that you have questions about, or want to know more about, please do let me know, because I can talk about it a lot. So, yeah, any questions you have before we go in? Anything you've come across in the material, or just any speculation you might have? That sounds like a no. Cool. So, I'm going to go through the list of things. What are databases and why do we use them? A database is basically anything that stores your stuff on a persistent medium. So that could be a relational database like Postgres or MySQL or SQLite. Um, it could be a JSON file, JSON server. The JSON file that JSON server uses is a database. I know that some other people say that it's not really a database, but it's totally a database. Writing stuff to a text file and reading it back in a certain way as a database. Uh, Mongo, non-relational databases, those NoSQL databases, a database. Um, there, there was a time when we had stuff on magnetic tapes that we had to do. Technically, a database. Uh, I think the notion of what a database is often constricted to relational databases, which is often what people are talking about. But uh, as long as it's stored somewhere and you can get it back, it's a database. Um, a cool pile of rocks you have hidden in the woods somewhere. Um, but yeah, so the important part is that uh, the data is persistent and we can get it when we want. Um, SQLite is an interesting example because it is structured as a relational database, but in a lot of implementations, like if I don't know if Render does this, but Heroku, if you used SQLite there, it would not write it to disk. It would run the database in memory, and when the machine booted, your stuff was gone. So it behaves like a database, but the memory was volatile. So, but people still call it that. Yeah, yeah. So, and the other thing that I think is there's some confusion on in some of the writing that you'll read. Most of the time, especially the times when we are doing it, people make a distinction between your server and your database, which is a good distinction when you're talking about developing an application that uses a database, and a React front end that hits that server that hits that database. In reality, they are all servers. Your web server is at the minimum going to be storing and shooting your stuff back through HTTP, or even doing the conversion that they would do with React. That's a server. Your application server is a program that's running. It could be JSON server. It could be something you write by yourself. Could be Rails. Could be Express. Anything that's taking requests from a front end and maybe hitting a database. And your database is actually also a server. You'll see probably if you're using SQL you can run, but a lot of like Postgres runs on I think it's 6.543, I think. It's just a server running on a port, and the way that we talk to it is by making a connection to the database on that port, sending it requests through SQL, and it responds in a certain way. So yeah, these are all servers. That's important to know because some error messages you'll see or some troubleshooting be like, oh, the server isn't running. You're like, my application server is definitely running. What it means is the database server isn't running. So everything, they're all servers, but we will normally talk about your server and your database being your application server. So the databases that we are going to be using here for the most part from now on are going to be relational databases. What does that mean? Relational database means that there is a structured way of when we define our tables in a relational database, we define them in a structured way. Each table, which you can think of as like a spreadsheet, has columns of things that are a certain type of things, and a bunch of records, and there are a collection of tables that are related or not. And if we try to do something that doesn't fit in that structure, we're going to get errors, which is good because it prevents a lot of both security hassles and debugging stuff. If you're throwing the wrong data at something, it's going to let you know in that way. There's still plenty of room to make bugs, but it helps in that respect. And the other advantage is it's also often faster because the data is kept in such a regular way. It's able to be indexed in a certain way, which basically means look at the stuff in it and make a little lookup table for it. So the access time is usually pretty good. So that's why most real applications are going to use a relational database. Yeah, that's all I want to say about that. So I mentioned we talk to a database using SQL. SQL is the structured query language, and a lot of people consider it a mistake, but it's what we have now. We have used it for a long time. It was originally an effort to like, oh, we're going to make communicating with this database look more like English. So we'll make select and froms and wheres and whatnot. And that works pretty well until you get a little bit deeper. And it's just like any other programming language, it takes a lot of learning. So, but yeah, everyone uses it. It's been in use for a long time, and it is standard, and it is a good way of doing things. The only way of doing things in that respect. So SQL is a language we use to do two different kinds of things. The first thing is manipulating the database itself, adding tables, changing tables, renaming tables, all that stuff. We can change the nature of the tables, altering the tables. Um, that's all stuff we need to do to at least set up our initial databases. Once we have things the way we want, the second function is to operate on the data that is in those tables. And SQL SQL isn't just one thing. Every database has its own little special version of SQL, but most of them share a common baseline, and that is at minimum letting you do CRUD operations. Reading from your database, creating inserting creating new things in your database tables. Um, inserting, changing data in there, and removing data in there, which is uh, most of what we do. And there's a lot of cool things you can do with the details there, but under baseline, doing create, read, update, delete in the database is what we want to do from our server, which is also going to be handling CRUD requests from the front end. So it reflects that functionality in a certain way. That's nice, and that's why we use that. So let me talk about that. Talk about that. Yeah. So the structure of a database table, like I was saying, we create the table itself, and that's just saying like, hey, we have a set of data called this. We define columns in that table, and the columns are the basically they would map onto the properties of an object in Python or JavaScript. So it'd be like name, email, age, height, whatever. So those are going to be our columns. And then when we insert data into the database, we're going to be inserting rows or records to those that have one or more of those properties, depending on what's required in them. So when we're talking about the structure of the database, we're talking about the columns usually. When we're talking about the content of the database, we're talking about the rows usually, or records, depending on who you're talking to. And so we have say we have a pet owner database. It has name, I don't know, age, whatever. Most records in a database, in the main tables of a database, are going to have an ID column, and this is like the ID that you've seen in our JSON databases. They're usually integers, usually unique numbers. The important thing with relational databases and tables is that ID, called the primary ID or the primary key, that's usually what's indexed on. So when we grab things by ID, instead of searching by name or email or whatever unique thing there might be, when we do a select using an ID, that's the thing that when we add things to the table, the database takes care of this indexing. So it says, it looks up, it has that number, and it points to a certain memory location, and it does some math to like be able to set up so we can immediately access that given the thing. So having a key, having a primary key that's indexed on is fundamental. You'll see that in pretty much every table. And those are also important not only for indexing, but because of the relational part in the relational databases. The relational part means that we have tables that are related some way. So I have pet owner and I have pet, and each pet is going to be owned by someone. Usually that's going to be referring, so we'll have, pet is going to have name, age, breed, whatever. It will also have something like an owner ID. That's going to refer back to the IDs in this other table. So it's a primary key in the main table that exists on. When someone else references it into another table, that's usually called a foreign key. And we'll see some concrete examples of that. Basically, the primary key, foreign key pairing is, again, fundamental to the way we're going to structure all of our data. All of our datas. Yeah, that's the like basics before we touch some code stuff. Any questions about all of that before we start typing things or anything you're curious about? Oh, good. Cool. Let me go ahead and share my screen here. And we're just going to be working in code. So we do that. Hey, look at that. Cool. Check order this. Cool. So when I start Zoom, can you see the menu bar up top, or is it just the blank screen and I'm dicking around for no reason from your end?
I think we can see it.
Cool. Yeah, every time you share your screen in Zoom, I'm sure you've seen this. It comes up with a little bar, and you have to go in and hide those so it's not in the way of everything. Um, anyway, hey, cool. I did a bunch of this already. Um, awesome. Yeah, why we use databases. Da, 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 yeah, great. We will talk about these as we do them because that's more complicated. Um, cool. So let me see. Where do you want to start? Um, yeah, so I guess the sort of there's two flows we want to talk about. We want to talk about um, the sort of flow that we use, our application flow, I guess, and then kind of like the flow we use to um, set up our tables and whatnot. So the application flow is going to be familiar to what you've seen in all the JSON-based ones. We have a front end. It's going to make some sort of request, get, post, patch, put, delete. It's going to make a request to some server through a RESTful URL or URI, and that server is going to respond with something. In the case of our JSON database, we have mostly just been grabbing that whole chunk and then using that data as we need, or maybe selecting specific records from there. We're going to be doing the same kind of thing with a relational database. And just instead of grabbing chunks of data or taking one object out of a list of JavaScript objects, JSON objects, we're going to be doing this in a more structured way with SQL. So the application flow should be mostly the same, except for the way we are accessing that data on the back end. Um, the way we set up and think about our data is a different thing. Let me take a look at what we have here. Cool. So we have a simple table here. This is for a dog walker application, and here are some owners. So these kind of match up with the properties on the classes or objects we're going to be working with. So if we have um, in Python, we have a dog owner, or we have an owner class that has a name, address, email, and phone. We'll want that to sync up with our relational database to provide the same kind of thing. You don't need to worry too much about how that's going to happen now because we'll talk about it when we get to ORM stuff. But it basically, your Python application will be using SQL to talk to the database and get data back. Cool. I have some bad data to look at. Look at this. The question is, what's wrong with this table? Anyone want to take a shot? Got our columns and rows here. Or maybe not wrong, because this is a fine table. Um, what what could we do better here? What things kind of stand out to you, if anything? The first thing that stands out to me is that we've got some duplicates in here. So these are the primary keys, and they have started leaf blowing right next to me. So if you can pick that up, that's what that is. Um, not distracting at all. Cool. So these are repeated records. They're different entries though, and they contain a lot of duplicated information here. um, And again, here's another example of stuff that is not great. If we have more than one pet, um, just putting them in comma separated things in your columns, in your rows, not great. Although, to be 100% honest, we used to do that a lot way back in the old days. um, so there are ways to structure your data, um, to make it easier to think about, and easier to hook up to Python objects. This is kind of rule two territory. It's, you can make your database do whatever you want. If you want to put multiple pet names and ages accordingly and pull those out and parse them and make it work. If it works for you, that's cool. It's not going to be as efficient, but that's rule three. It's not going to be as easy to understand. That's going to be rule two. So the way that we want to kind of pull stuff together is, instead of putting everything in one big table, right? We want to kind of make these tables correspond to the way our objects are going to be designed. So in this case, we have owners and we have pets. And so instead of having a long owner one, like it looks like this, that has all the pet information smacked all together, or a long owner one that has the pet information encoded in a weird way that way. This is technically called first normal form. There are four normal forms. Don't worry about it at all, even a little bit, unless you want to become a database administrator. But this is the kind of standard way to pull things out. We're going to create a table for each one of our objects, or each one of our classes, and each row will basically correspond to an object in that class or derived from that class. And then we're going to add the properties as columns in our tables. And ideally, there shouldn't be any repetition. But look at this. We have two entries named Luke, age 2, domestic long hair. The way the data is set up, I'm going to assume that those are two different dogs that coincidentally just have the same name, breed, and age, and are owned by the same people. Adam has two dogs named Luke that are exactly the same. They're twins. But each of the owners has their own row, and this PK, this is the ID that we can use to hook up to our pets here. So it feels a little backwards sometimes when we have our owner IDs, we have our pets. We have to think about it in a certain way. We think, we might think, oh, our owners own pets, which is true. But in our data here, since we have one owner that can own multiple pets, this is a one-to-many relationship, it's called. And so since an owner can own more than one pets, we're going to keep the owner IDs in the pets table. And so the thinking is that pets are owned by an owner. An owner owns many pets. That means that we're putting those over here. Again, not super intuitive, but you'll get used to it as you get more experience with it. I don't think these other pings really have useful stuff. Yeah, I don't know. Yeah, we'll come back to look at that shortly, I think. But what I'd like to do is, that's all too much. Yeah, let's look at the database again. So, yeah. Just want to make sure I'm not missing anything here. Yeah, cool. So, databases are binary files. They're files that are like more literally made up of ones and zeros than a text file is. They're the same under the hood, but text files are interpreted a certain way to make it look like there are letters. Binary files do not have that restriction that they need to look like letters. So we can't really look at it in a browser like that. But there is an SQLite Explorer. I think it's called Explorer. Oh, that's what it says there. There's an SQLite extension for VS Code, which lets us do queries and look at database structures and whatnot here. So we can't open it directly from here. We can open it from here. To get that, I just right-clicked and said Open Database, and that opened this up here. And then it had to pop open the SQLite Explorer. So we'll look at this. So we have a dog walker database that has one table right now, owners, and that table has an ID that's an integer, a name that's text, an address that's text, an email that's text, a phone that's an integer for some reason. I would not have done that, but that's the way it is. So so here, this view, we can see the properties, the column names and types. We can look at the table here. We don't need this anymore. We can have it show the table here. I don't need that anymore either. There's one thing in the table. ID1, Adam is a name, the address, the email, the phone. So there's one record in that table. And we also, in this extension, can do queries on a database. And a query is basically a set of commands. So I'm gonna split this. I don't want that. Cool. So let me double check, make sure we can do this. So if I say select minor note, you're gonna see uppercase stuff in SQL a lot. That is nice to have and nice to look at sometimes. It is not required. It is case insensitive most of the time. So I just want to select everything from that table. So I'm going to say select everything star from, and then I'm going to give it the database name there. So I'm going to select from owners. And SQL always needs a semicolon at the end. That's just the way SQL is. We can run this query and it should give us the exact same thing. Cool. So we can select all the things from a table, and this is our R in the CRUD. This is our reading. A read in SQL is going to use select. So let's well, you know what? Let me go ahead and you know what? Let's start from scratch here. I would like to run this SQL over and over again and start with fresh data each time. So actually, I'm going to get rid of this table. Let's say drop table. And so this is one of the two main ones, drop table, owners. This is one of the two main ways you can interact with the database, or one of a couple of ways, I guess. You can get rid of a table. You can get rid of a table just by saying drop it. Drop just means delete in SQL. If we run this query, that should go away. Hey, look at that. Why is that table still there? Should not be there. Show table. Hey, there we go. No such table. Owners. Great. So that table should be gone. Let's see. Why don't you go away? Okay, well, as far as SQL is concerned, it does not exist. If we tried to do our select star from owners, that would shift command Q. Great. I don't want to quit. No, I don't. See? Why would you do that? Shift command Q. Yeah, no. Look, no such table owners. Great. So, and that will show us the actual SQL is being executed there. So let's go ahead and create this table again. So the way we create a table is by using create table. And so we just need to give it the name. So owners, and one of the syntactic peculiarities is that tables are usually plural named because a table is going to contain a bunch of different things, whereas classes are generally singular. So we'll have a owner class, a dog class, a customer class. Just kind of works out that way. It's easy to get mixed up. This is a matter of practice. Get the hang of it. So we're going to create the owners table. To do that, we need to give it what is in that table, or more precisely, what those columns are going to be in that table. We have we have our ID, we have our name, we have our address, we have our email, and we have our phone. But we also need to tell it what kind of things those are. So ID, I think, was an integer. Integer, great. Names, these are all going to be strings. And this is still a number for some reason, or an integer, I guess. Great. There's only one more thing we need to add here. Since this is our primary key that's going to get indexed, say primary key. Great. And so now, if we run this, in fact, I'm going to put the drop table up top. Yeah, I'll probably give you an error, but we'll see. Just so when we run it again, it will blow away the thing that we did before. Should give me an error. Is it still creating the thing though? Nope. Okay, can't do that first. Let's just create the table first. Hey, there we go. And now if we run it again, it should be okay. Great. So here's our table. There's the SQL for it that got executed, and there's nothing in it. So we can do our select star from owners, and if we run it, it should give us nothing. Great, great. So, while we're here, let's go ahead and make the pets table while we're at it. Pets. First time. Cool. Our pets table is going to look kind of the same. We're going to create table pets, and we'll add a bunch of fields. We're going to need an integer. That's our primary key. We're going to need a name. That's a string. Age. That's an integer. We're going to need a breed. It's a string. Yeah, we'll start there. Cool. And just for kicks, I'm going to do a select all from pets as well. There will not be anything in there, but there's all our stuff. So we ran these SQL statements to do that. Select from owners, select from pets. Great. No responses, but no errors, which is good. So let's I'll talk about the alter. If you want to change the table after the fact, add columns, rename things, you can do that. There's a alter command. Ideally, you won't have to do that too much, because you can always drop it and create it again the way you want. When we get into migrations and stuff like that, we'll talk about that more. But for now, this is the basic stuff that you need to know for this. Cool. So that should all run. Great. We did it all. Awesome. So let's talk about getting some data in here. Oh, dash is the comment there, so that's legit. Can I collapse these? Yes, I can. Sweet. So we've set up our tables. Now we want to do our first, we already did our first action, our read action, which is a select. We would like to add some stuff to the table. So our create action in our CRUD is called inserting into the table. We're inserting a record into the table, and that is going to be with the insert keyword. So the syntax is a little backwards. We're going to say instead of saying we're going to insert something into owners, we're going to say we're going to insert into owners, and then we're going to give it two things. We're going to give it, oh, and white space doesn't matter in SQL, which is why you need the semicolon there. So we can put stuff on different lines to make it look nicer. So what do we have in owners here? What do we have in pets? Oh, let's refresh that. That's what it was. Cool. So we have owners and pets. So let's insert into owners. We're going to insert, let's give it the fields first. Name, address, email, and phone. So we're going to insert those fields, and we need to give them the values. And we're basically going to give them the values that line up with each of these. So let's say John lives at 123 Main Street. Hotmail. Phone number, we'll give a number 1, 2, 3, 4, 5, 6, 7, 8, 0. Great. Yeah, and we'll close our yeah, that's fine. Close that off there, and now we can see that we are inserting. I wonder if it makes more sense to put it down here. Can I do that? I bet I can. Put it down here. Nope. All right, that's fine too. I'd like to make this down here. Nope. Make it down here. Nope. Left. I want down underneath. There we go. That's what I want. Cool. So now I can see that I've inserted some stuff. I need to put our semicolon at the end. Let's go ahead and run that query, and we'll do a select at the end. Select all. With our semicolon. Run that. Great. There's our one entry in there. Cool. I have a couple owners here that match up with a table that we just saw. So I'm going to copy paste those in there. Loop. Great. Hey, that's highlighted all nice for me. I wonder why this is all highlighted nice. Cool. I'm going to comment out this stuff since we've already done it. So it's not going to run all the queries every time. But now let's run this query and see. Nope, now we got John twice. That's fine. We got all our users in there. It's totally fine. Okay, well, let's talk about this in just a minute. I'm going to go ahead and insert a bunch of stuff into pets, I guess, too. Those all have different fields. Oh, well. Let me go ahead and type those in, I guess, while we're here. Or, I'm going to copy paste them and then just pick the ones that we want. Blam. So what do we have for pets? Name, age, and breed. Name, age, and breed. And we don't need all this other stuff. Boom, boom, boom. Delete. Name, age, and breed. Great. Get rid of that. Get rid of that. Get rid of that. The most fascinating part of programming. And there we go. I wouldn't get rid of those two. Awesome. So now, I am going to uncomment these because I don't want to have all these duplicates in here. So let's execute this whole thing. Did all the things, and at the end, great. Here's our John. We didn't do a select at the end, but we can do our select at the end. Select everything from pets. Let's just run this whole thing one last time. That'll comment some stuff out. Great, and there is all our pets. Cool. So that's how we insert things. Basically, we insert them by saying insert into the table name, give the fields we want to insert, and then give the values. We don't have to insert a value for every field unless it's required. So if we just wanted to add the names of a bunch of owners, we could do that. Not incredibly useful, but sometimes it is. Oh, I see. They're in quotes and not. Great. So I'm going to go ahead. Since we have this all set up, I'm going to comment out our Mickey stuff. I'm going to comment out our query stuff or insert stuff. Great. And now, well, that was useful, but not what I wanted. Um, I'm just going to leave the selects there. It's down here. Cool. So now the important part is just our selects. Let's just run that. Cool. So now we have our list of owners and our list of animals. So that's the C part of CRUD. That is basically all you'll need to know. Any questions up to this point?
Yeah, I have one. Um, for the additional owners that you added,
Mhm.
the phones are strings, not integers. Does that not matter?
Um, you know what? In this case, it doesn't seem that it did. Did I make them strings up here? I made them integers. Um, I guess it is smart enough to convert those strings into numbers.
Cool.
Good catch. Normally that wouldn't fly. That shouldn't fly. I wouldn't, if I was a database, I wouldn't let it do that. But SQLite is a very lenient database in a lot of ways.
Earlier you were saying that you wouldn't have made the phone numbers integers. What else would you have made that?
I would have made it a string probably, or if we were wanted to be strict about stuff, I would probably have four fields or however many we need that have like country code and area code and that. Um, there, it really depends, right? Um, Integers only go up so high also, so depending on the length of the phone number you might run into problems there. um, I think because phone numbers are such a weird, they're not just numbers, right? They have a bunch of different parts to them. So I would look at our use case. What do we care about the phone number? Do we just care about displaying it back on a form? Yeah, and just store it as a string. Strip out the parentheses and dashes when we take the input, store it as a string, and then figure out how to display it when we get out. Or a number might be fine. If that works, that works. Um, it's a matter of preference until it bumps up against the requirement, basically.
So in the lessons on Canvas, they were using integer and text.
Mm-hmm.
Is there a big difference between the text and string?
There is a difference. There's not a big difference.
Okay.
Again, every database does it a little bit different. There's text, there's string, there's varchar, there's long like, extended text. Um, I think in SQLite, and I have to look this up to be sure. Basically, strings are up to like 256 characters, whereas
Okay.
text can be up to like 1K, I think.
Oh,
Uh,
wow. Okay.
but they usually have to do with the amount of text in there. And the way it's stored, text I think text and string, don't quote me on this, I think they store them as a fixed size of the field, whereas I'm pretty sure SQLite has a varchar, which basically means it's a variable length field and it stores it as a variable length, which means it's maybe slightly less efficient to get, but takes up less space. So that's a trade-off there. But yeah, every database has their own kind of peculiarities when it comes to text. And yeah, so string and text are pretty universal. Those are going to work in most databases. So that's kind of what we're about too. Yeah.
Okay. And one additional question. Is VS Code and the SQLite extension your preferred way of viewing and manipulating SQL data, or do you ever use the DB browser?
Um, it is now. I used to mostly just do it on command line. So
Yeah.
you get a command line and just say SQLite. So I think
Yep.
if I do here, I can say
You could do that too. Yeah.
SQL like 3, I think it is. I think I can give it the database. Let me actually go into the repo. It shouldn't matter because it's a server that's running, so it shouldn't matter where you are in there, but just to Flutter, this is Python and SQL. Yeah. So if I do SQL like 3, I think it lets me give the name of the database. So dag walker. Nope. Okay, cool. So I can do SQLite 3. And then let's see, open database. Great. Oh, because it's working off of file names, right? So I do open. I'm not in that directory, am I? I think it's going to be. Oh no, it should be that way. I'll go into the assets directory just to make sure. This is not important. Dog walker assets. And there's our dog walker DB. Nope, it's back one. There we go. Oh, I think I can do SQL. So I'm not giving it the database name. I'll give it the file name. Yeah, there we go. And so if I do select all from pets, I should get all of our stuff there. Yeah, I generally don't spend enough time in databases to like have a preferred way of doing it. This way is just fine for me. But the graphical browsers are also really nice. I'll definitely use when I'm using Postgres, different kind of database. They have a really nice client for that, so I'll often just use that to poke around. Yeah, there's a million different ways to look at it. It's a matter of preference.
Okay, cool. Thanks for that.
Anything else before we move along?
I have one more about the phones. Is
Yeah.
there a reason that Adams doesn't have the zeros at the start?
Yeah, because it looks like it converted a string into an integer there. That's part of the conversion process.
Okay.
That would be my guess. But this would be another great reason to use a string if those were significant for some reason. I know area codes won't start with 0, but if the phone number started with 0, which I don't think they do, if you have significant information in that, I would probably store it as a string. That's what happens when you convert a string into a number sometimes. Good catch, though. Good eye. Anything else here? Cool. I'm actually going to delete all this stuff here. So now if we just run this, we're just going to get queries like that. Great. Cool. So the create part, pretty straightforward. Let's talk about queries a little bit. Yeah, so the default query you're going to do like this, just show everything about everything. Let me just work with pets for now. So if for some reason I just wanted to get the names from pets, and this is an interesting, subtle, but useful in the future point. The way that these are returned, so the database tables live here. These are not those tables. These are the responses as a result of a query from those tables. These are also kind of tables, though. They're kind of like virtual tables that exist just for the moment. And you'll see if I do a select name from pets, this should give me a table with just those names. If I select ID name from pets, this will give me IDs and names. This will become useful later. But sometimes you only want, if you're doing, well, if you're writing your own SQL and you only want to get back, a list of IDs or a list of emails, you can query for one or more columns by name. Most of the time, just because of the way that programmers treat databases, you're going to be running get everything query and then probably selecting out of there, depending on what level you're working with your SQL. It's the trade-off of using an ORM, whether it's SQL Alchemy, MySQL, what's the one I like in Express? objection, I think it is. They will often, the SQL produced by them is often not as tidy as it could be. So if you watch the SQL that happens when your server runs, sometimes it'll like make a query for everything, and then you will like just pull the part that you want out of that whole response. So often it is responding with stuff that you don't need. But that's a rule 3 thing. We don't care about it. So most of the time you're going to be seeing select everything from pets, or select all the specific table names from table. So if we only want some things here, so if we only want to get the domestic long hairs, that looks like a thing, we can narrow down our selection. So we can say select where, and so now we can give it a field. So we'll say breed, and we'll say equals domestic long hair. And if I'm doing this correctly, which I believe I am, it should give us just the first 2. Or none. Up. H. There's an H in hair. Look at that. Great. So we can do that. We can say where name equals rows. Boom, and just get that one. So we can specify different things to select on. Most often you'll be selecting it on an ID, or you often won't, the ORM will. We can also do numeric stuff. We can say select from pets where the age is less than 10. And that should just give us the other 3. I am great. We can do that. Yeah, that's most of what we want to do with basic gets. And there's, again, every database has their own special set of things that it lets you do. SQLite is a little bit limited, but the documentation is really good. So if you're wondering if you can do something, look it up, and you probably will be able to, or not, and then you'll use a different database. So there's that. These selections are also not the selections, the restrictions also work great with other operations. So the easiest one is delete. If I want to delete, if I just said delete from pets, that would get rid of all the pets, and we don't want to do that. But we can say delete from pets, and we can get rid of our old friend Rose. We can say delete from pets where, we can put a name, age, breed, whatever we want. I'm going to do the, hello Scrolly. I'm going to do the, let's get rid of Rose. So where age is greater than 10. So we would delete all the pets that are older than 10 years old. Sorry about that, Rose. If we do our select again, there she goes. So you can use that same where syntax for deletes. You can also use it to change things. These are going to be our updates. So we can say the syntax is update pets, and we kind of need to do a where here because we are updating specific entries. So we say update pets, and we're going to set something. So we're going to set, let's set the age. Yeah, let's set the age of Chop to 9. So set age equals 9, where name equals Chop. And we'll do our select. So if I've done that right, put a semicolon at the end, that should, and the execution order is kind of backwards. So first it's going to do the find the where name equals Chop, then it's going to set the age of that. So it's going to look at pets, look at chop, set the age. Am I lying? Let's find out. Nope. Look, we did it. We set the name, set the age. And you can do that too if we want to do all of it. All of a sudden, everyone is a beagle. We can just say update pets. We can just set set breed equal beagle. And if we don't do aware, it's just going to update all of them. So that's our create, delete, update, and write. Create, write, create, read, update, delete. That's what it is. So that's basically all the basics there. Any questions about these? And believe me, I look this up every time I use it. So unless you're writing SQL regularly, you will be too. Cool. I'm gonna go ahead and put all my pets back the way they were. Just undo a whole bunch. I want to show you one more thing. Cool. Let's just uncomment all that. Great. And run this again, and we'll get everyone back in business. Great. So pets. Select owners. So we've got our two tables here. So, what if we wanted to, did we set a foreign key on this? I don't think we did. Let's go ahead and alter this table. Why don't we? Let's alter table pets. Did I not have the foreign key on there? I think I was just a picture. I'm going to alter table pets. I'm going to add a column. I'm going to call that column owner ID. And that's going to be an integer because these are integers. And I'm also going to call it, can I do that in SQLite? I think I need to walk that. No, I think I have to do it the other way around. I think I have to say add column. You know, I think I need to do it like this. Add column foreign key owner ID integer. Nope, I don't need to tell it's an integer. I just need to say references, maybe. Yeah, that looks right. References, then I say owner ID. I'm not convinced that's right. I'm on a 50-50 chance on it. Nope. Okay, cool. I want to go back and just add it to the table definition then. There's a way to do that. I don't want to look it up right now. Cool. Create table pets. So here's where I would add foreign key, owner ID, references. Yep, owner ID, owners ID. Did I just spell it wrong before? Maybe. Cool. Let's go ahead. Blammo. Nope. Unknown column owner ID. Oh, maybe I need to do them in the other direction. If I have owners. So no, that's right. What was the error it gave me? No such table pets. Yeah, we know that. Great. Let's try this again here. Unknown column owner ID. Maybe I have to add it first. Owner ID. Great. I don't need that anymore. Let's just run it again and see. Table owners are, thank you. One more time. Hey, let's go. Great. Cool. So we don't have owner ID. Let me go ahead and add some owner IDs when I'm adding the pets. Here are our pets. I'm going to get rid of John. Sorry, John. Let's see. Here's our owners. Here's our owner ID. And I'm just going to enter in, let's see. What do we have? Adam. Oh, it's excuse me, 1 and 2 this time. So 1, 1, 2, 2. How about that? Great. One last time. 4 values for 3 columns. What? Mm-hmm. 4 values for 3 columns.
The insert to, do you need to add the owner ID for the other ones?
I sure do. Yep, you're right. 100%. So it's copy paste and get you. Hey, there we go. Cool. So now we have owner IDs and whatnot. I'm just going to comment these out because who knows when I'll need them again. Cool. So this is what we look like. So pets 1 and 2 are owned by X. Pets 3 and 4 are owned by Adam. And now I would like to be able to select the owners or select the select the pets that are owned by an owner. So let's see. Yeah, let's see what that is. So say I want to get all of Adam's pets. What am I going to do? I'm going to select star from pets. And well, what do I want to do? I want to select from pets. Well, I could just do this where owner ID equals 2. That should give me the pets I want. I'm going to get query. Hey, that did that. What if I don't know the ID offhand though? So this is a one-to-many relationship. And I'm going to want to select, say I know Adam's name, but I don't know what ID he is. So how do I construct that query? That's a great question, me. So I'm still going to want to do select from pets. I know the owner, owner.name equals Adam. This is not going to work, but I'm just going to walk through it. So if you want to refer to something in another table, you could say table.property. I'm 90% sure this will not work. Good. No such column, owner.name. Great. So let's think back to what I said about these things. These are kind of temporary virtual tables. You make a request, it says, here's a little table of your results. And then we're just looking at them now. What if we did something besides look at them? So what I would like to do is make a little virtual table that consists of these two things smushed together. What would that look like? Great question. Yeah, I'm going to keep those up here for now. So I am going to use a new thing called a join. And what join does is it joins tables together. There are multiple kinds of joins, which we're not going to go into right now. But basically what it does, join creates a virtual table by smashing 2 tables together in this way. And I'm gonna write it. I'm going to write it the way you're going to see it most of the time, and I'm going to change it just a little bit to help see what's really happening. So I'm just going to select everything pets. And I'm going to say join. Hey, that's a word. And so I'm going to say owners because I want to join on the other table. Owners. And I want to say the way I want to join it. So in this case, I want to say where the pet's owner ID equals the owner's ID. So this should get me a table that has all that stuff smashed together for all of the entries. So I'm selecting from pets, join to this. Let's see what that looks like. Cool. So it looks like it's all slammed together, which is what we wanted. And since we're selecting from pets, it is, so basically we're selecting from the pets table. For each entry in the pets table, we're going to look this up. And then we're going to find, this is basically where part instead of an on, that can be a where. We're going to take each one of these entries. We're going to look up what the owner ID is, and we're going to find the corresponding entry in the owners table and smack that into one big table here. Cool. This is left join, it's called. There are there's 8 different kinds of joins. You'll mostly only been using a left join or an inner join. Don't worry about that right now. This is just join. So if we wanted to get the pets information, and we don't care about the owners, we could just say select name, age, and breed from the pets where we join the owners on that. And there's our, nope, column name. Ambiguous column name, because both owners and pets have names. So I could say pet dot name and go from there. And so now we're just getting the pet's information. But because we got that big old list of stuff, we can select on whatever we want. So we can say owner's name, and email. And so that will give us a table with not that. Owners on pets, error here. What did I do? Commas. I need commas. And so now I can get whatever information I want combined off of that table. Most of the time, you're going to be wanting just stuff from that left table, depending on who owns it. But when you do a join, you get all the stuff, so you can pick and choose what you want. And so if you, I don't know if SQL Alchemy supports this, but if you have objects that are made up of conglomerations of data from multiple tables, you could do a join query to create that object. It doesn't necessarily correspond to a thing in a table. But yeah, so you can do joins to get all those things. This is for one-to-many relationships. There are also many-to-many relationships. I don't know if I want to go into them right now. Yeah, and we'll talk about them on Monday, I think. Yeah. But so this is a way. Briefly, many-to-many relationships require that you make an additional table. In this case, it would be like owner's pets, and it would just have IDs hooked up to each other. But that's a little bit more complicated. We'll talk about on Monday. But for right now, this is breed. This is pretty much it for SQL basics. What is ambiguous? Yep, pet's name.
You also put pre instead of breed.
There we go. It's getting late. There we go. Cool. The one thing that helped me understand the joins better as a super small little thing, was really hammering that the join creates its own little subtable that you're selecting from. The one little change I had to make in my brain to make in queries to make this make sense in my brain was just doing that. Exact same query, but now in my brain, it's saying select from pets join owners instead of select from pets join up with owners. Again, this only works for this kind of joins, but mentally it kind of helps underscore that this join creates a little virtual table that you're selecting from. But yeah, that's SQL basics. This will not be on the code challenge. And you may or may not use it in your projects, but it's good to know going forward. What questions do we have?
These can get very big, huh?
What's that?
These can get very big.
Oh yeah. Huge. Millions of records, dozens of tables, depending on your app. I mean, imagine exercise for the reader. Think of something quote unquote simple like Twitter, right? Imagine just for the basic functionality. Imagine like users, posts, follows. Think about what the table looks for that, and think about what the size of that table is. Ridiculous. You will probably not be getting that far, hopefully. And SQLite has limits, so you can't really use it for real stuff. But it's really good for learning. Last call for questions.
Kind of in the same vein as that, are there ways to make it so that like these operations don't make, millions of entries long tables that you don't actually need? Like,
yeah, and if you have millions of users, you're going to have millions of records in that table. But you're never going to be doing give me all from that. You're going to be saying give me a user, whose email address is this. Give me a user who was created between these two times. You're always going to be narrowing down these queries. You're not going to. It's very, very rare that you're going to want to say select all 8 million users I have.
yeah, okay, cool.
In your case here, you may wind up doing that just the same way we did, load in everything from our JSON databases. But in a real application, you'll rarely do that, except for like reporting purposes. All right, last call. One more time. Cool. Here we are again. Yeah, so that's the basics of SQL. We could teach a whole course just on SQL if that was a thing you wanted to do. We are spending a day on it, which is not enough. But yeah, it's just enough to understand kind of what's going on and to be able to debug stuff when you see it, hopefully. Once we start hooking it up to SQL Alchemy, you'll need to know less of it. So good or bad, depending on what you're looking at. Cool. Anything else before we shut this down?
You said SQL will not be on the code challenge?
SQL will not be on the code challenge.
And what about SQL Alchemy?
No, that'll be next time around.
Cool.
Yeah, technically, SQL Alchemy is part of phase 3. And we are not doing it in phase 3. Short version, for lots of different reasons. But there's enough already in phase 3. Cool. I'm going to shut down this Zoom. Instead of hanging out for 10 minutes and coming back, let's just do stand down when I hit the end button or when I hit the stop recording button. Cool. I'm going to hit the stop recording button. Thank you, anyone who's watching.